Okay, here we go. What we're going to do, this is a continuation of what we were talking on calculus and math and what we call the stair step to heaven, which is one of the interesting points of calculus is that we were calculating points along a graphed line that shows that this point, anywhere on it, there's a particle of movement or a rolling ball, or however we want to look at, describe or view this ball moving through space and time, say. And along it we've come up, Newton came up with a way to calculate its speed and direction, and that's called calculus. Well, one of the big problems, one of the interesting areas that Newton wanted to work with, and he had to formulate it in his two principles of physics, and one of the areas deals with inertia, and that inertia is very difficult to work with our present concepts, and when we discard the nature of spin and precession of a particle. But once you include and have the necessity to accept that the spin and precession of a spinning particle or object will have a very big effect on what calculus and what we are calculating, and why spin and precession would be the major reasons Newton, of course, considered the necessity of inertia. Okay. Now we would think that there would be no such point as inertia. And this goes right in with the concept of why we have a difficult time describing zero. Why have such a hard time with zero? What is zero? Some people would say it's a number. Some people would say it's not a number. Well, of course, zero is not a number. But we still have trouble conceiving of that. And right now what I would say is that whether it's a number or not a number, it helps us understand that zero, when we throw in this idea of spin, that particles spin and that particles will precess, and that when we understand this, that all items are in precession in their spinning mode, they're under the influence of precession, that we can now more understand why zero would be so important, and why it doesn't necessarily have to be a number, and that it could much more readily be conceived of as a point that is not part of the number chart, but it is a very important point. It would be the point of what Newton considered inertia, the inertia point. And as we touched on right at the very last of the last segment of the stair steps to heaven, and Mr. Gunn of the University of Texas back there in 1970s was trying to get a better feeling for this, why these points were so important. Well, these inertia points, and why calculus looks like a stair-step affair when you graph it out and take a look at it and really think about it, is that calculus is measuring the movement of an object over a span. And in an area such as what we're dealing with right now, all particles would be under consistently their movements would be consistently influenced and are a description of precession. Now there are those particles, of course, that move very far out and for a very long time without precessing by an outside intervention of force. Those particles may be what we would consider the radiant energy of suns, the radiant energy of mass that has been able to travel very far away from the center of mass areas. However, what we know within our very close realm of all viewable space is that all particles right now in viewable space would have to be under a very strong influence of precession. There'd be no way out of this precession. So what we're going to state is that Newton's inertia point, which is the point from which we calculate a given motion, action and reaction type of thing, is that this inertia point is basically, as we had stated earlier, that point in which an object in spin is spinning. It is its axis of spin. Now that will give us our inertia point. Now when the particle or item that we're trying to describe its motion through space, once it is acted upon by an outside force, we're going to see a precession movement. This is your point of calculation. This is where we start with Newtonian calculation, and this is where we start building our stairwell to heaven, because we will measure along that point until it changes again. And we call these functions. We come up with a formula for each of these functions. Well, what we're basically measuring as a particle moves through space, well, there we go. I'm going to have to possibly redo this to reevaluate. I may have not made the points very well, but we'll get back into zero, inertia point, precession of a spinning object, and how all this ties together to give us Newtonian physics and movement of objects and particles through space. Okay?